Remember, the question is cross-tabulation between gender and employment status. So here we need to push gender either into the rows or the column section. It does not matter where you push the variable because ultimately your result will be the same. Okay, so let us see. Let us push gender into the rows section and employment status into the column section. For now, let us ignore statistics. Let us go to the cells section. Here, all of these might be unticked for you. However, make sure to tick the observed section. Why? Because that is what we are trying to see. We are trying to see the number of people, number of males who are employed, number of females who are employed, number of males who are unemployed and females also who are unemployed. So in case you want to see that, you will have to fit in the observed frequency, right? So you need to tick the observed section. Expected part, it is up to you whether you want to tick it or not. Expected count shows you the count that is expected if there is no relationship between the variables, that is, if the variables are independent. That means if employment status does not depend upon gender, that is, if gender and employment status are independent of each other, then what count you would expect to see in each section, that is the expected count. So it is up to you whether you want to check that or not. I'll check that just in case. Right. And also let us check the percentages part. Row and column. Okay. We will see how that works out. So let us press continue and let us press OK. This is the output that SPSS will show you. Here, there are 391 cases that I have in my data. In that, this is my cross-tabulation section. This means 109 males are unemployed, 110 males are employed, so that the total number of males is 290. Similarly, for the females, 145 females are unemployed, 27 females are employed, so that the total number of females that I have in my data set is given by this 172. This is my observed count, or what my data tells me, right? Here, if you look at the column totals, however, you will see 254. That means the total number of unemployed people in my data set is 254. And this column total is 137, which means the total number of employed people, irrespective of whether they're female or male, are 137. So that I have 391 cases in my data set, right? So this is what the cross tabulation of observations tell me, what my actual data tells me. Expected count, as I already told you, is nothing but the count that you would expect to see if there is no relationship between gender and employment status, right? So the expected count comes in handy there. However, it is pertinent to mention that if you want to carry out a test of association like the chi-square test, which I'll not be covering today because that is beyond the scope for today. If you are doing that, it is important that your expected count in each cell is greater than 5. So in case it is less than 5, you need to add up rows or columns, whichever way it is. Right. In our case, it's a very simple cross tabulation. There are only males and females and employed and unemployed. And here all the expected counts are well above 5. So we need not bother about that. Okay. Now, why did I tick the row percentages and column percentages? In my case, I had pushed gender into the rows. Here, if you see, the row percentages display this percentage within gender. That means 49.8% of the males are unemployed and 50.2% of the males are employed. Remember, it is within gender. So within males, how many are unemployed and how many are employed? So that it totals up to 100 for males. So unemployed males plus employed males will make up 100% of the males. So this is the row percentage that I was talking about. Next comes the column percentage. If you remember, we had pushed in employment status into the column section, right? So once we had done that, this gives me the column percentage. That means out of all the unemployed people in my data, 42.9% are males. Whereas of all the employed people in my data, remember that is the column here, of all the employed people in my data, 80.3% are males. Similarly, if we come to the female section, we see that amongst females, 84.3% are unemployed and only 15.7 are employed. Whereas amongst all the unemployed people, women constitute a majority, and amongst all the employed people, women constitute a minority, because more than 80% males are employed, whereas only 19.7% constitute the total employment in the data set, right? Right. So this is what the cross tabulation broadly means. So it is up to you. We can easily not have the row and column percentages. We can easily simply take this part and ignore the expected row column percentages, continue, and then press an OK. So you'll get this simple cross tabulation, which simply tells you the number of employed males, unemployed males, employed females, unemployed females, right? So this is a simple cross tabulation or a tabular representation of the data that we have at hand. Whether these two categories, see, what the data is telling us here is your employment status and gender may not be independent, right? Because as you can see, it is heavily favoring the males. In the employment scenario, more males are employed, and in the unemployed scenario, huge number of females remain unemployed. So from the cross tabulation itself, you may be able to get first-hand idea regarding what is going on in your data set. Then, of course, the statistical tools come in, wherein you can analyze using the same cross tabs. You just have to go to statistics, click on chi-square, continue, and then you will get the chi-square results. But I'm not doing it here because it is beyond the scope of today's session, right? But that is an option which you can explore, and that is where cross tabs help you in getting first-hand information regarding your data set. Hello, is there any question? No, I guess somebody got unmuted.
Ma'am.
Yes.
There is one question in the chat box.
Yes.
Neha Singh is asking, could you please tell how to check Cronbach alpha on this data set?
Well, see, that is again beyond the scope of today's session. So maybe some other day we'll do that, right? Okay, or you can, I'll give you my details. We can have a chat about it.
Sure.
Okay.
Sure.
Yeah. So, yeah. I'll give you my email ID at the end of the session. You can anytime get back to me. So I guess we have covered the first exercise that we had set out to do, except for the bar chart part. Yes, we are talking about tabulation, but SPSS allows us much more with a single click. So let me, without going into the graph section, we can prepare a graph in SPSS. Let us again go to analyze, descriptive statistics, cross tabs, and continue with the example that we were doing. As you can see, there is an option below, right? Display clustered bar charts. So you can simply click on that and you can also suppress your table. So what this would do is, this would not give you the tabular output. It would give you the graphical output or a clustered bar chart. You can also not suppress tables. It's up to you. So let me not suppress tables and simply display the clustered bar chart, right? So let us see the result we get. See, this is again the cross tabulation that I was talking about, which we got. So this is in tabular form. And with a single click, we have also been able to come up with a bar chart which shows us, and this is a clustered bar. Why is it a clustered bar? Because, you know, there are different subsections within the gender category. So, you know, employed and unemployed are both together. They both appear together under males and appear together under females, not separately. They are clustered together, the employment status. That is why this is a clustered bar chart. I'll of course discuss bar chart in detail in my next section when I discuss graphical representation. Here, as you can see, this represents males and blue stands for unemployed males. So if you can have a look at your table also, unemployed, there are 109 males and 145 females. So as you can see, blue stands for unemployed. So here this is approx 109 only, yes, and this is around 150-ish. So that is the 145 part. Similarly, the employed part, 110 and 27, this is around 110, and of course this is less than 50, this is around 30, so 27. So what we have been able to do is, while preparing a cross tabulation, we can also see the graphical output. So this is a huge advantage in SPSS, which we do not have in tools like Excel, right? Now, of course, with this bar chart, we can do a lot of things. I will come to that when I specifically talk on bar charts, right? We can do a lot of formatting, changing colors, shortening the length of bar, the breadth of bars, and so on. But that is for the next section. Let me proceed to my next example. So I have covered the entire example number 1. I hope it is clear. Let me check. Yes. Jatin Basumatari. Yes, that's a very good question. But again, that is a little bit beyond the scope of today's discussion for me. However, I'll try and give the answer to you in gist. What we do in SPSS is, if you have a range of numerical values 500 to 1000, 1001 to 1500, we recode them, right? Like here, this is my data set. What I will do here is say my income. My income ranges, it's huge, right? See, if you can see the first income, it's 11,999. Then it is again 10,000. Then it is 3,500, so on and so forth. So if I want to make class intervals, which I actually have done, if you see my standard of living part, that has been coded with the help of income only. So it depends upon you. What you can do is, you can use data, transform, recode into different variables, and then, you know, you can have the input variable as income. Then you can change these labels and all, and old and new values allows you this. Have you seen the range? Say 0 to 1000, you can put value 1. Then 1001 to 2000, you can put value 2 and keep adding that. And then you will come up with a new categorical variable having those categories. You know, like I have come up with a categorical variable, standard of living, from income itself. So I have coded it as 1, 2, 3 with my own range. Okay, so you can do that using transform, recode into different variables, and use that option and see. I hope it helps. Okay, so then you can make it categorical and then you can proceed with cross tabulation. So have I been able to answer your question, Jatin? Yes. So in case you need further assistance on this, I'll give you my email ID. We can have a chat on that as well, right? But that is a little bit beyond today's scope. So yeah, maybe later. Now, let me move on to the second question that I have, it is very similar. You know, we have to cross tabulate education level or marital status by employment status. See, it is the same thing, right? I'll try and twist it up a little bit. Let's see. So this is my data set one. Again, analyze, descriptive, cross tabs. So my question was education level and employment status. Of course, you expect them to be correlated, right? So yeah, if you're highly educated, you think you should be employed. I mean, that is the general way we think. So let me push education level to this side. So when you're pushing variables, you have to be sure they are nominal or ordinal. You cannot push in scale variables right there, right? So variables have to be nominal. So this is the symbol of nominal variables. So we have pushed it in. Say we are looking at education level versus employment status by gender. So what I'll do is I'll push in gender in the layer section. Okay, and I'll put off this clustered bar charts because we are done with that. So again in cells I have put only observed. So let me see, let me press. Okay, right. So this is my cross tabulation. As you can see, I have got education level across 1, 2, 3, 4, 5, 6, 7 categories. These are the categories of education level that I've considered. And what do these numbers tell me? See, the layer gender has come in also here. So 21 males who are not literate are unemployed. Similarly, 6 males who are not literate are employed. Again, 0 males who are postgraduates and above are unemployed, which is to be expected. You've gone further with your education, you expect to be employed, right? So 3 males who are postgraduates and above are employed. Similarly for females, see, 18 females who have studied up to higher secondary are still unemployed. Only 5 of them are employed. So this is how you can bring layers inside your tables as well. So it is not necessary for cross tabulation only to be two-dimensional in that sense. You can add your layers as per your preference. Okay. Not necessarily, actually. Yeah, I'll get back to the questions later. So, yeah. Okay. So I hope this has clarified, you know, what else we can do with cross tabulation. Now, let us again try religion with employment status by gender. So we may be thinking that people or women or even males of a particular gender may suffer from more unemployment than of another. So let us see whether that is true or not, at least from the table. For statistical test, of course, you'll have to run the chi-square test. So this is education level. Let us push it that way. Let us push religion here and their employment status by gender. So let us see whether anything is here or not. So, well, for that, yeah, you'll have to go deep into the tables and then see amongst females, maybe, 13 of the females professing Islam are unemployed, whereas only one is employed. Uh, Whereas amongst males, the ratio is a little better. Amongst Christians, again, it's very equal when it comes to males. When it comes to females, again, not that equal. Very few are employed. Same with Hindus as well. See, so you can see across religions, actually, if you leave out Buddhism and other religions, across Hindus and those professing Islam and those professing Christianity, there is a lot of inequality as far as the employment situation goes between males and females. So a bird's eye view of the situation you can always get through tables. However, I repeat, in order to infer something statistically, you have to perform a test, and in this case, you'll have to perform a chi-square test. So let us see how a bar diagram looks. In this case, if we display clustered bar charts, so what does it show us? So see, what it is doing now, SPSS, is it has taken layers. Do you remember we had pushed in the layers as gender? So what it has done is it has given me two separate graphs for the layers. So for males, there is this graph. For females, there is this graph, right? So here again, blue is unemployed, green is employed. So you can see from the graph, a lot of Hindu males are unemployed and so on and so forth. So you can infer from the graph as well. So using the cross tabulation function, we have been able to do so many things, and you are able to do even more things, statistical tests, different kinds, which I'm sure will be covered in other sessions. Now, let us move on. Um, you can also tabulate uh, social group with employment status by gender, so on and so forth. So number 3, 4, and 5, I will repeat using another tabulation option available in SPSS, which is not the cross tabulation option. And we will now see how the outputs differ, right? So let us go to my data set. This is my data set. Now, again, analyze. For any kinds of tables, you always have to go to the analyze option. Let me go to not descriptive statistics now. Let me go to tables and use the option custom tables. Now, I'm sorry. Yeah. You will have this view when you open the custom table section. And let me tell you, in any kind of research paper you're writing, or any kind of analysis, this is an extremely handy tool. Custom tables part, it does work in seconds, and you can get a lot of information from a single table. So we will start slowly. We will start it with a 2 by 2 table only. Now let us tabulate religion by gender. Okay, so we start slow and we'll see how it goes. So it is up to you where you want to push in your rows, what you want to push into your columns. Now, if I want to see it in this way, so if I want to push religion to rows, what I'll do is I'll click here, and then the categories of religion will automatically show below. Okay, as you can see here, all my categories of religions are showing. Now again, I'll go to religion and click here. Then what I'll do is I'll press this and I'll drag it to the rows section. You'll see a hand appear and you need to drag it to the rows section. Okay, so then all of these religion, all of it will show. So this in itself is a table. It will give you the count or the number of Hindus in our data, number of people professing Islam in our data, so on. So let us see, let us just press OK. So this is my output, wherein you can see the number of people professing Hinduism is highest, followed by those professing Christianity, followed by those professing Islam, and then Buddhism, and then others. I've got no Sikhs or Jains or Zoroastrians in my present data set. Okay, so this is a bird's eye view of my data with respect to religion. Now, again, let us now make things a little more complicated. So let me press on gender. As you can see, there are two categories. They will show here. Simply click here and drag this to columns, right? You will see the hand appear there. You will just leave your mouse, right? So as you can see, it has made a table out of itself. You can now find the number of Hindu males in your data, number of Hindu females, so on, so forth. Let me press. This count symbolizes that. It gives you the observed frequencies, right? So let me press OK. So this is my output of religion versus gender. So I've got 115 male Hindus in my data, 73 female Hindus in my data. I've got 14 female Muslims in my data. I've got 68 male Christians in my data, so on and so forth. Okay. Right. Now, a little more complicated. Okay. So let us now bring in a little more spice. So religion with employment status by gender. Okay. So my employment status, as you have seen, symbolizes unemployed or employed. So let me see what we can do with it. So again, analyze tables, custom tables. So let me put employment status. This is my employment status variable. As you can see, there are two categories which show themselves here. So what you simply can do is put your cursor here, press the mouse, drag it whichever way you want to the rows or columns. I'm pushing it to the column section. Mind you, if you put it here, you will get a different output. We don't want it here. We want to know how many Hindu males are employed, how many Hindu females are employed, how many Christian males are employed, how many Muslim men are employed. So I do not want to put it here, because if you fine, you can get data like this also, but it depends upon your use. If this is useful to you, well and good, fine. See, 123 male Hindu, 123 Hindus are unemployed, 65 of them are employed, so on. However, you do not get the intersection point between gender and employment status, and we want to see that, right? Because we generally think that the situation is pretty unequal amongst the two genders. So let us now see how to do that. Okay. Let me go to my data set. Yeah. Again, analyze tables, custom tables. Let me pull this down here where your count is showing. Now just pull it down there, drag it down there. Now the table that you get will show you the employment status according to each gender. So I think this will be a little more useful if you're performing any empirical analysis. As you can see here, 63 of Hindu males are unemployed, 52 of Hindu males are employed. However, only 13 Hindu females are employed, whereas 60 of them remain unemployed. So again, this gives you the same information as the cross tabulation did here, but it looks and feels so much better here, right? Do you agree with me? This is a more clear view of the data than you got from maybe the cross tabulation section. This is also pretty clear, but then, since you're reading through 3 different layers, things may get a little muddled. So this is a better representation in some way. So maybe, you would want to stick to this sometimes. So this is a different way of presenting data. The main part where custom tables are more convenient is, you can represent quantitative variables also using custom tables. Okay, let us see how we go about doing that. Now, analyze tables, custom tables. Okay, let me remove the employment status from here. For removing, all you have to do is again, click it there and drag on the left hand side and drop it there. Because we picked it up from the left, we have dropped it back to the left. Let us now introduce a scale variable, a continuous variable, income say. You want to check whether income is consistent across genders or not. So let me push back religion also now. Let me simply pull income below the two genders. So as you can see, SPS is automatically on seeing a quantitative variable because it has been coded as a scale variable in my data. It has automatically given me the option of mean, right? So what this output will give me is the average income of males in my data and the average income of females in my data. The beauty of this is, if you want to check the total income also, what you can do is simply again click on income here, go to summary statistics. See, here mean is highlighted because SPSS automatically gives you the option for mean calculation once you push in a scale variable in custom tables. Say I want the total income of all males in my data and all females in my data. What will I do then? I want the total. So I'll remove the mean, push it to the left, and I will then go for something known as the sum. That will give me the total. I'll push it to the right, apply to selection, close. See, now sum appears here instead of mean. So if I press OK now, what I get is the total income of males in my data set. So it is 23,49,840 rupees, and the total income of females, which is 18,10,017 rupees. So it depends upon you what you want to do with your data, how you want to visualize it, right? So if you want to make things a little more interesting, you can now check for, say again, let me get back to the mean because that is more interesting, right? Checking whether the averages are same or not, that makes more sense. So I've again brought it back to mean and say, what do I do now? Social group. Let me push social group to the rows. So categories and totals, if you click here, you can click on total. It will give you total across all categories. Apply and OK. Let us see what this gives us. So what this does is, this gives you the, see, can you see that under total, this 10730 is the same as the mean male income. That is under the total column here, you know, male income mean. So is 10730. However, by different social groups, amongst the scheduled tribes, the male mean income is 10,889 rupees. The mean female income is 11,034 rupees. And the same way you can infer across all the different social groups, right? So it all depends upon you. You can nest and nest and nest. There can be n number of layers to your table. Even if your table becomes huge, SPSS will take some time, but will give you that output. See, let us now maybe take um, employment, is rather education level here. So, you know, now you'll get a huge table. Okay, how do I remove this much? So yes, so now you will get a huge table. You see, I have put in education level as well. So what SPSS will do now is, across social group, across genders, and across education levels, you know, it will give me the mean incomes. Okay, so you can add as many layers as you want in custom tables. And this is the biggest advantage of using custom tables. It makes analysis and life really easy, you know, any kind of analysis. So because you have the option of hundreds of things that you can do with it. If, you know, categories and totals also, you can have totals across rows, across columns. If you click here on top on gender, categories and totals, click total, apply. Across social group, click on social group, categories and totals, it's already there. So wherever you want to change something, you simply need to click on that and highlight that. Even if you want totals across education levels, you can simply click here, categories and totals, total, apply. So then you will get all totals, you know, as you can see, it will give you all kinds of totals across rows, across columns. So it will give you, you know, like there are n number of possibilities that you can explore with this. Another interesting part is, For your scale variables, summary statistics, you can have hundreds of options. You can have, you can find the range, standard deviation, variance, the percentiles, everything. Whatever you need to find from your data, you can simply do that in tabular form without making any calculations yourself. You simply push in these here. SPSS will calculate and give you that output in the form of the table itself. And that is why I say custom tables are an extremely important tool in any statistical analysis. If you know custom tables, your life is really easy, right? So I hope I've covered the tabular section of things pretty much. So I'll be doing, yes, I think I have answered this question, differences of cross tabulation and custom tables. In cross tabulation, essentially the look is different, the look and feel. You can add, there's some echo. Dr. Sundararaj, I think, is saying something. No. Okay. So in cross tabulation also you can add a lot of layers. However, you do not have the luxury of adding quantitative variables in your cross tabs. Cross tabs are essentially meant for only attributes or qualitative or categorical variables. However, in custom tables, you are free to use scale variables as well. Not only that, SPSS will also give you various kinds of outputs for those scale variables, whether it be the totals, whether it be the means, whether it be standard deviation, quartiles, whatever you want. That is possible only by using custom tables. Whereas cross tabulation is not only used for tabulating categorical variables, it is also used for carrying out tests of significance for association also, which is not the case in case of custom tables. So both of them have their uses. However, if tabular representation is what you want, proper and quick tabular representation, I will always recommend custom tables because it is more flexible. It is more in your hands as to what you want to do with it, right? So the primary tabulation part, I guess I have covered. Now I will do a little bit of thing which I'm sure all of us know. It's a simple frequency distribution, but I just want to show you how within a frequency distribution also you can have different plots without specifically going into your graphical representation option. Yes. So let us go to my graphical representation questions now. So number one, it's very simple, I have, let us find out the frequency distribution of social groups and plot a bar diagram. So I just want to have a look. See, we can do that in custom tables very easily also, na? How many people are there across my social groups. So that is very easy. So let me push all this back. And you'll be thinking that, why on earth are we now doing this through frequency distribution? I'll tell you why. So this is how my custom table section would look, and this is my distribution of people across different social groups from my data. As you know, there are 391 data points, and the maximum of people here are belong to the schedule type category.
Hello.
Yes. Hello. Was there a question? No? Okay. So, yes. And now I want to show you another very simple option so that, for simple things like these, we do not need to go to the custom tables option. Custom table option, you should go when there are 2 or more variables involved. For a simple thing like this, what we essentially do is we go to analyze, descriptive, frequencies, and say, social group we want, right? So we want to know the frequency of people in social groups. Please click on display frequency tables, otherwise your output would be nothing, right? And let me not click this because it makes no sense. Quartiles for a nominal data. Charts for now, fine. Let us put in a bar chart. Continue. Okay. So what this will do is, this will give you this kind of output, which is much simpler. If you are dealing with one single variable, it hardly makes any sense to go in for a lot of uh, customization using custom tables. So frequency works just fine. It has given you the same output. It has given you the percentages as well. Valid percent is nothing but, uh, excluding missing data. So I have no missing data. As a result, it is 100%. And this is the cumulative percentage. What it has also done is, it has given you a bar. You see, bar diagram with actual numbers. So as you can see, 179 people belong to the scheduled tribes and so on. So with a single click, you can get that as well. You have another option here under frequencies. If you go to chart, see, I've clicked bar chart, right? If you do not click on frequencies and click on percentages, it will nicely show you the percentages as well. So see, around 48 to 50%, 48% of your data or 47% of your data is scheduled tribes. Yeah. So see, 46% and close there. This is around 7%. So yeah, it is 6.6%. So you have the option of plotting your actual count as well as your percentages as well with the use of a simple frequency table function. But be sure to click on display frequency tables if you want to have the table. If you do not want the table, you just want a graph, no problem. You get a graph without the tables. You have to uncheck the display frequency tables option, right? Okay. So this is pretty simple. So yeah, I just thought, I'll give it a go. Now, find out the frequency distribution of household size along with its mean. So this is a scale variable, my household size. So if I want to find out the frequency distribution of household size along with its mean, what I'll do is, I'll go to descriptive statistics, frequencies, display frequency tables. I'll push this to the left. Double click also does that. And this arrow also does that. So it's up to you how you want to use it. So um, household size, where did it go? This is my household size. I pushed it to the right. And if you notice the question, it says frequency distribution of household size along with its mean. So yes, to find the mean, you have to do nothing special. Simply go to the statistics section, click on mean, because I want my mean. If I want quartiles, I'll click on quartiles. If I want median, mode, whatever, standard deviation, variance, you're free to click on whatever you want, skewness, kurtosis. So for me, let me just check the mean. What is the mean household size for my data? And I don't want a chart. And yeah, so yeah, this is my data. So in my data, I have got homes with sizes 1 to 11. So 11 is my maximum, 1 is my minimum. So as you can see, I have clicked on mean, right? So the mean household size has been displayed in the statistics section as 4.64. So on an average, in my data, there are 4.5 people, around 5 people in a household, right? Okay. So, and these frequencies tell me that there are 3 households whose size is 1. There are 120 households whose size is 4. You see, it's heavily centered here, around 4 and 5. That is why this mean came out here, right? So, there are 77 households with household size 5, so on. So, this way you can calculate measures of central tendency, measures of dispersion, also using the frequencies option from your analyze section. So it is extremely helpful. You are also free to plot, uh, other charts like a pie chart, say. Okay, histogram won't count here because histograms only work for continuous data. So let me see. Sorry. Yes, pie chart. Let me see how the social group pie chart looks. So of course, you know, this is the ST section and the colors. This is the SC section. This is the general section. This is the OBC section. So, and then, you know, you can go on and modify. I'll definitely come to that, how you modify charts a little later. So I think, yeah, we are done with the frequency distribution section as well. So we have explored 3 ways of tabulating data. We have explored ways of plotting data also through bar diagrams and pie diagrams within those tabulation scope itself and without going into the graphical representation bit. So I hope till here things are okay, because then I'll move on to the actual graphical representation section, you know, moving on from tables actually. So no questions here. Okay, right. Yeah. So we go to our question number 3. Plot the number of people living in rural and urban sector. So as you can see in my data set 1, this sector variable has 2 values, that is rural and urban. Okay. So I want to see, to visualize the number of people living in rural sector, number of people living in urban sector with the help of bar diagrams, and then I'll come to changing the background color and all of that. So first let me plot a bar just as in a bar and not go into the tabular section. So how do we do that? There are multiple options for us to plot a bar. The easiest of them is to go to the graphs option, from there legacy dialogues, because I find this pretty easy. I find this easier than the chart builder option. I'll also show you the chart builder option. So what I usually do is I go to graphs, from there legacy dialogues, from there I select bar. You end up with 3 options. We are going to explore all the 3 in today's session. So this is a very simple bar. You just need to plot the number of people in rural and urban section. So I'll click the simple option and, you know, we'll select the first option only. It works in most of the cases in real life. So we are not going to change this. We are not going to alter this. So let us define, right, I'm sorry. So I want the, what will the bars represent? The bars will represent the total number of cases. So remember my question, number of people living in rural and urban areas. So I want the number. So in number of cases. So I've clicked on this number of cases option, where in my sectors, rural and urban areas. So I have pushed that into my category axis. Okay, because my question is very simple. So along my x-axis, I will have rural and urban, and along my y-axis, I'll have the number of cases in each. Okay, these parts I'll come to, but a little later. So I'll press OK. Let us see. Yes. So we get this output, which tells us that there are, you know, less than 250 people in the rural areas, from rural areas in my data, and less than 150 people in the urban areas of my data, right? Now, let us play around with the graph a little bit. So, and then we will come to the a little bit more complicated portion of nesting the bar and all that. So before that, let us have a little bit of fun with the colors. So for changing the background color, the depth of the bars, or the bar colors, the first thing to do is you have to click here. You have to click inside this graph, you know, here, so that this portion becomes activated. Okay. Then you double click here inside your graph, right? You will have option now. So you will have another window popping out like this. So what have I done? I've simply produced my graph. Then I've clicked on this graph and then double clicked on it and this window pops up. Now, let me right click on this area of the graph. So remember, when you're right clicking on this background area of the graph, all the options will be relating to the background area only and not the bars. If you want to change something regarding the bars, you will have to click inside, right click inside the bars. But we will go to that in my next section. First, let us click here on the background section of the graph. If you right click here, you will get the option. Remember, this is a right click. Okay, you'll get the option properties window. Now, this has all that you want to do, all the colors that you want to play around. So as you can see, my present background color is this very faded grayish greenish thing. So it gives you the preview here, right? Because I'm not changing my chart size. I'm letting it be the same. So I'm in the fill and border section directly. So in the fill section, fill meaning filling up the background, right? In this case, because I've right clicked on the background. So in my fill option, let's put in a little bit of yellow. So this will give you the preview. Okay, so the background is yellow for me now. And let me apply this. You see, once you apply, behind you, your graph's background has changed color, right? Even your border, the border of the graph, remember, not of the bars, because we have right clicked on the background, not on the bars. So in the border style, you can change the weight of the black line, that is the rectangle that is there. If I put 2.5 and apply, you see what has happened? My border has become a dark black in color. I have a stark border, stark contrast there, right? So in this way, what I have done is, and this last option variables will simply give you what is there. Sector is in the x-axis, count is in the y-axis, and I have a bar chart, right? So we end up with this kind of a graph. Now, what if I want to change my bar color because it's not going well, right? With this yellow. So now I'll right click inside my bar. To change anything relating to the bar, I have to right click inside the bar. So I'll go to my properties window again. You see, again, you have a fill and border option. So inside the fill and border option, you see the preview is this greenish color. So let's say I want to make it this color, right? So I've selected that color, just clicked on that, it gets selected. And say the border style. Remember, now that you have right clicked inside the bar, the border style will relate to the border of the bar itself. So here the weight is 1. Let me increase it a little bit. Let me make it 3 then and apply. And you see your bars are now stark and you have a different color. You can reduce again this, so that it remains a little better. So this is what you end up with. Okay. Now, if these bars are looking too big to you, what you can do is you can go to the depth and angle section. Okay. Say, let's put a 3D bar instead of this 2D bar. Again, let us go to the bar options. Okay. You can see, this is not a clustered bar. This is a simple bar that we have selected. So this option is deactivated. In the bars option, you see 75%, that is why it is this huge width. Width is 75%, so it's huge. So let us reduce it to say around 30%, and let us apply. So you remember what we have done? We have put a 3D bar, apply. Remember to apply, otherwise it won't get applied. Huh? Bar options, 35% apply and close. So then you can again close this as well. So do you see a different looking graph, a different looking bar than what we originally had? So we have added a 3D effect. We have changed the background color. We have changed the bar color. We have changed the border, and we have made it into something different. Okay. Now, what if we want to add, you, of course, you know, for your research article paper, whatever, you're writing something, you would definitely want to add titles to your bar. So again, what will you do? You will double click inside, left click, double click. Then once you have double clicked, here you will right click and you can add title. Okay, so you can simply click here. Once you click on title, this option will come. So you can simply select this and write figure 1. Okay, so this is done. This is figure 1. This option you can also get from the options section of adding a title. Here, see? Again, you can add another title on top. This is graph 1. So, you know, I've added another one on top. So it depends upon you what you want to do with it. In case you don't want something, you can simply press delete and that will vanish, right? This has become a little messy. Yeah. Yeah. So options title. Okay. So yeah, you can put in titles. There are many options. Whatever you want to do with it, you can do. Options. You can add a footnote to your graph, you know, right below. See, the footnote section appears here. So you can write a footnote that, you know, source PLFS data. So that is your footnote. So then you can close. So it is done, right? So this is my chart editor section. You can simply close this and you'll end up with this on your output. So whatever you change in your graph editor, that will automatically reflect in your output. So this is all we can do. We can change colors, borders, add titles, add footnotes, do n number of things with it. If you can explore a lot. You can even push in a text box here. You can show grid lines. Okay. You can also enable the data labels. This is not enabled here actually. This we'll do when we'll do box plot. So fine. So for now, I guess, yeah, this is all about your changing background color, bar color. We have made the bars 3D and reduced the size of the bars as well. So this is all about formatting my bar chart. Next, we go on to, we actually will try and visualize the difference between simple and clustered bar chart. So for that, first we'll do a simple bar chart of the same thing and then a clustered bar chart of the same thing. Okay. So we want now, question number 4 is rural and urban sectors by gender, right? So first we will go for, close this, this is taken up a lot of space. So yeah, data set 1. So I want a graph. So I'll go to the graph section, go to legacy dialogues, go to bar, go to a simple bar, define. So now I want by gender, right? So I will push the gender in the panel section, panel by gender. So this will give me the number of people living in rural sector from males, females, so on and so forth. Okay. So let me press OK. Yeah. So you see, we end up with this through a simple bar diagram. So this shows me that these many males, more than 125 males reside in the rural section, rural sector, whereas, you know, around 110 females reside in the rural sector. In the urban sector, around 60-ish females and around 75-ish males. So this is one way of looking at it, because here you have got two simple bars actually, which are paneled by gender. You remember I'd given the option panel here, right? So that is why it has given me this out. So you can give another column in a panel by social group or maybe panel by religion, whatever you want. You see now you'll have this kind of a data set wherein, now it becomes more, there are, of course, because religion has come into play. So you'll have a panel of gender, you'll have a panel of religion, and you'll have rural, urban, rural, urban, rural, urban within this as well. Okay. So this is the way you would do it if you are doing it using simple bar diagram in more than one dimension. However, there is a better way to do it using clustered bars. So let me select the clustered option. Okay. So in my clustered option, let me select. Oh yes, Dr. Rachna, can you please type out which steps you want me to repeat? I will do that. Absolutely, no issues. For which one?
Just last one. Religions.
The last one, religion.
The
Okay.
basis of religion.
Sure. I cannot actually hear you well. There is some network issue, but what I could get from you is
Yes.
that you want me to repeat the one with the religion and gender, right? Yes. So that is the, yes, sure. I'll do that now. Then we'll go to the cluster. Fine. So here what I'm trying to see, visualize is the number of people, the number of males as well as females who belong to different religions living in rural and urban areas. Right. So for doing that, I have got two options. One is using clustered and one is using simple. So I have been doing simple only till now. I haven't gone into clustered bars yet. Using simple bars, how I would do it is, I would go to graphs, legacy dialogues, bar, simple, define. So in my category axis, of course, primarily I want to see the number of people living in rural and urban sectors. So that is my category axis. Okay, that is what you basically want should be in your category axis. Your subdivisions would come in your panels always. Okay, so I want to see it by gender and religion. So I've pushed sector into my category axis. I'll push gender into one of my panels and I'll push religion into the column panel. Okay. And then I'll write okay. So you end up with this kind of a graph, which tells you visually religion wise, gender wise, distribution of population in rural and urban areas. Right. So this is what I have done using simple bars. Dr. Rachna, is it okay now for you? Does that work for you? Yeah, I hope it's okay. If not, you can always push in a message. Okay. So now I'll try and do the same thing using.
Yes, ma'am.
Yes.
Yes, ma'am. Yes.
Yes, the network condition is actually terrible, na? So your voice is coming in a very, yeah. Anyway, chalo, no issues. Okay. So now let us do the same thing using a clustered. So let me define, okay? So first of all, I want my category axis again, rural and urban areas. I think you're saying something, Dr. Rachna, but I just couldn't make out anything. If you could please type it out in the chat box. Yes, great, excellent. Thank you very much for your response. Yes. So as you will remember, we are trying to do the same thing using simple and clustered and check out why cluster bar may look better or why simple bars may work out for you, right? So sector is my main thing here. I'm trying to look at the distribution of population by
Thank
rural
you,
and
ma'am.
urban sector. So that goes into my category axis always. This is your primary level of investigation, what you want to look at, right? Next, let me define these clusters by, gender. You have to define your clusters by something, otherwise your OK option will not be activated. Why? Because you are doing a clustered bar. So if you're not defining your cluster, then you won't get a clustered bar. So your SPSS will refuse to show you an output. So if I just push it back, you see this OK option is no longer activated, right? So it is up to you what you want your cluster to be. You may want religion to be your cluster. You may want social group to be your cluster. For me, since I'm looking at the gender side of things, so let me push gender as my cluster. But you have to remember, unless you push in the cluster here, you will not get this OK option here. You'll not get a graph here, right? Right. So I'm trying to do with a religion angle as well, but I'll get into that later. Let me do this simple graph first. So now you see, this is my graph for males and females. You remember we had got something like this from the cross tabulation option only somewhere. So, you have different ways to arrive at graphs. So directly from graph also you can, from the analyze section also you can, descriptive stats and all. Chalo. So see here, I have clustered by gender. So as a result, blue is male, green is female. So in my each sector, which is my primary variable sector, it is clustered by gender. So it is sector wise, gender wise. That is why it is a clustered graph. And maybe this looks a little better than this, right? Than your simple bar diagram, which shows the different genders on two different graphs. See, this is in a single graph, and what it does is it facilitates comparison. And the primary, what should I say, motive of any visualization is for you to be able to infer something from that visualization, right? So I think, since this is aiding comparison, here you see females are all worse off in both rural and urban areas, maybe a little less worse off in urban areas. So you can infer that much from here, right?
The
Worse
same
off in
we
this,
got,
yeah.
ma'am.
Yeah.
The same we got in cross tab also, ma'am.
Yes,
Where
yes, yes.
gender versus employment and unemployment. That was that.
Yes, yes, absolutely. So that is what I'm trying to show. I'm trying to show from where all you can draw graphs, like not only from the graph function, you can actually have the same graph from various other sections as well. However, if you go from the graph section, there are a few more additions which you can do, which we'll be doing now, introducing religion and all that you cannot have from the crosstab section. That will be a little difficult. Okay. So I mean, there are various places. Once you sit down with SPSS and you start exploring all of these, it's a huge gold mine. So yeah, I encourage all of you to do that. So now let us see what else we can do with it. Let us push in religion now. Graph, legacy dialogues, bar, clustered. We are working with clustered bars presently. So let us see how by religion it's working now. Okay. So let us press OK. You see, now instead of these many graphs, you have these many, and they look a little better, aiding a little bit more comparison, right? So yeah, this gives you the count. So there are around 60 Hindu males in rural areas, around 17 or 18 rural males from Islam in rural areas. So it aids a little bit of comparison. In amongst Christians, again, you see the females, number of females are more in urban areas. So clustered bars actually aid comparison when you're comparing two or more categories across different variables. You can do that using clustering. Okay, so thank you very much, Arunima. Thank you. So this is the way you can use clustered graphs. There is another thing that I want to add here. You see, we have been plotting continuously the count Why only count? You can also plot the percentage of cases. So the percentage of males, percentage of females also instead of the exact count. So you see here, now if when I press the percentage button, I come up with this. So this tells me around 30%, you know, in rural areas, there are 30% Hindu males. So it gives you a better comparison when it's in percentages rather than counts. It aids, facilitates comparison. So you have got n number of options for yourself to decide whether you want to use percentages, whether you want to use absolute numbers, whatever it is. Right. There is another thing we have done. We have covered 4, 5, 6, and 7 in the meantime. Okay, so these are done. So you can also consider quantitative variables here. Okay, so how will you do that? Say, where is my data? Yeah, graph, legacy dialogues, bar. So let me go for a simple bar only. So let me remove a few of these, otherwise the thing gets a little complicated. So I've kept my category axis as sector. That means I want to check out what is happening in rural and urban areas, or maybe, you know, you can put gender also here. I want to check out what is happening in case of males and females in terms of their income. Okay, so I pushed in income to the variable section. How? By, see, pushing other statistics. See, when you're plotting a bar, what you will do is either select total number of cases, percentage of cases in case of categorical variables. However, if you want your graph to display information on a quantitative or a scale variable, what you need to do is click on this other statistics section. Then this variable option becomes activated. Have you seen? If it is N, then this is not activated. If you click other statistic, it is activated. Then I'll push in my income variable and see it is showing me mean income. I'm fine with it. If I want, I can even change it. I can change it to the median of income or the total income or a percentage above a particular value. Whatever you want to do with it, it's up to you how you want to play around with it. For me, I want to check out what is happening in terms of income between males and females. So let me try out this form. Okay. Yeah. So you see, you come up with this kind of a bar wherein you have got gender on one side and mean income on one side. That is, I have plotted a categorical variable against a scale or a continuous variable, right? And you see, in my data set, the mean incomes are almost equal, which is great news, right? Females are a little bit less, but then still almost equal, almost there, right? So this is the way to plot categorical against quantitative data. The only thing to remember is in that case, you will have to activate this other statistic option and then push in your variable and change this according to your convenience, what you want to look at. Okay. So there are many options that you can go on with it. Here, if you can see, there are the option titles, right? Once you click on titles, this is, you know, you can write your line 1 income versus gender. Say your line 2 is graph number 2. Your subtitle is simple bar chart. Say your footnote is source PLFS. Continue. Okay. So now you see, without your having to double click and activate, through the simple bar option only, we are now able to put in the different kinds of headers and footers and everything like that. And then of course, you know, you click here and then right click here, properties, change the fill, change the color, do whatever you want with it, play with it, and then you see. So there are various options It only waits for one click of yours to explore that. Okay, so we are done with okay, plotting the mean household size against sector. So I have changed this to mean income against gender. Let me now plot to mean household size against sector. See, again, it's the same thing, right? If you notice, my household size is a scale variable, whereas my sector is a nominal variable. So as you realize, you again have to go to this other statistic, push income out, pull household size in. This should be scale again. It has, yeah. So pull household size in. Sorry. Yeah, sector will go here. This will go out. Household size will be here. So, you know, we're done. This will again give me the same titles because I have not changed the titles. However, this is totally wrong. This is not my title. So you can change that when you're practicing. Okay. So this gives me the mean household size against each sector. Okay. Fine. Now we come to, yeah, we have also given title of the graph and done all of this. Right. So till question number 10, we are done. Now for question number 11, repeat question 3 using stacked bars. So there is one more option left for us to explore, which is the stacked bar. So what was our question number 3? Number of people living in rural and urban sector. Pretty easy, right? We'll just see how it differs when we use the stacked bar option. So let me click stacked, define. So let us forget about this. Again, we are interested in, my main variable of interest here is I want to see the distribution of population across rural and urban areas. So I'll push sector to the category axis. Okay. And remember, this is a stacked bar. So unless you define your stack, you cannot press this OK, SPSS will not activate it. So what I'll do is, fine, I'll check it by gender. Let me see the total number of cases. So titles, there are none. So if you want, you can put one stacked bar. So let's continue with it. Let's press OK. So we end up with the stacked bar. What it has done is it has stacked one variable on top of the other. The stacking variable, remember, was gender. So it has stacked males here and females here. So one top of the other. Okay. So it depends on what you want to stack, how you want to show it. So here it shows me that around, you know, these many people, 110 or so are males in rural areas, and from 110 to around 240 are females. So that would be around 130. So that is a distribution of, rather, I was wrong. That is the other way around, 130 males and 110 females. So that is what this bar displays. Okay, so this is the stacked bar. It is used very less. The reason being, as you can see, it is not very apparent, right? I'm having to make calculations. I'm having to go from 110 to 240 and then calculate, okay, fine, the difference is 130. So there are 130 males. So it is difficult. You want your graphs to speak for themselves. So this is one reason why stacked bars are very used a little less than the other kinds of bar charts. Okay. Right. So we are done with bar charts. Are there any questions on bar charts?
No, ma'am.
Yeah, fine. So since there are no questions, I'll move on to histograms now. Now, we need to understand one thing. Bar charts, you know, do not require continuity of data. Okay. However, whenever you talk about a histogram, you need continuous variables. Otherwise, you cannot have a histogram on rural areas. You cannot have a histogram on urban areas. You cannot have a histogram on gender. For having a histogram, your x-axis will always have to represent a continuous, that is a scale variable. So as you can see in my data set, I think income and household size, these would make no sense. State code and district code, having a histogram of them would make no sense. Having bar charts makes sense there. So income income and household size are the only variables from which I can think about constructing a histogram, right? So what a histogram would essentially do is it would, give me the frequencies of each interval. So let us see how it works. So income histogram with panel as gender. So let us make a histogram. Achha. Okay, I'll talk about chart builder right at the end, because I'll do everything from legacy dialogues only. So legacy dialogues histogram. Okay. So continuous variable I require. So I've pushed income on the right hand side, and let me see how my histogram looks. Well, does this make much sense to you? See, it's not telling me much, right? There are unequal 1, 2, 3, 4, 5, 6. There are 6 bars from 0 to 10,000, 6 bars from 10,000 to 20,000. So it's not telling me much, right? So when constructing a histogram, you need to have a little bit of a clear idea about your data. So as you can see, what this graph has shown me is, I think my data has around 0 to 50,000 range. So let me try and divide my data into 5 parts, or the histogram into 5 bins. So let me see how to do that. So how do I do that? As usual, I double click inside. Okay. Now I click inside one of the bars because I'm trying to change the width of the interval. So I have to click inside the bars. Now I right click. I go to my properties window and it takes me straight to the binning section. Can you see binning? Bins are nothing but the widths of your class intervals, right? So since I do not know exactly, I haven't formed class intervals, but I know that ideally there should be around 5 intervals from 0 to 50,000. What I can do is, instead of this automatic coding which is on now, I can go to custom, push my number of intervals as 5. Okay, and apply. So now you see the data makes sense. See, I don't know from where this came, but yeah. This this line I have no idea about. Okay, I didn't draw one. So here you can see from 0 to 10,000, there are around 210 or so people. Between 10,000 and 20,000, there are around 150 or so people. Between 20,000 and 30,000, there are around 35 or so people. Right? So histogram always have to be interpreted with caution. The first thing to remember, yes, Neha, which part, the histogram? Yes, yes. So in a histogram, what you need to remember is the first thing, you are plotting a continuous variable on your x-axis. Okay, so here I've taken income. If I simply plot it without changing the bin width, it will show me something like it had shown me some time back, which is lost now. Yeah, so income. Okay, so yeah, it has shown me something like this, which actually doesn't make sense because I do not know this number, say the 60 is against which category of income earners. This 60 refers to earning what income, because I cannot see my class interval here, right? That is why what I decided to do is, I decided to double click here, enter this, click on the bars, right click here, properties. It takes me straight to the binning. Binning means the width of your interval. Bins are nothing but the widths of your class intervals. So I know between 0 and 50,000, maybe I should have 5 class intervals, which would suit my case and which would make more sense. So I click on custom, number of intervals 5, apply. And then you see the result shows. If you do not click on apply, it will be the previous one only. So then this changes to this, which now is a much clearer version for interpretation purposes. It tells me between 0 and 10,000, there are 210 people roundabouts. Between 40,000 and 50,000, there is only one person maybe. See? So you get more clarity of the data only by changing and altering the bin width to suit your data. And that you would know the data that you're handling by checking the range of the data or whatever, you should have a proper idea. Yes, Neha, absolutely. Your number of intervals will be according to your data set. So maybe, you can simply run a frequency of your income variable. Say in my case, let me run a frequency of my income variable. Okay, that is how it works, how I work usually. I check for the minimum, maximum, mean, right? Continue. Okay. So here you see my minimum income is, I don't know why I got this pie chart. It was clicked, I think. The minimum income in my data set is 2,000 rupees. The maximum is around, say, 40,000 rupees. So here this is zero actually. So this is displaying zero. So you see, you get an idea as to what your interval should be, how many intervals you should have. So on the basis of that, maybe you can put in. So it is very much varying from data to data, and it is your call what you want to do with it, right? Now, inside a histogram again, you can do the same thing. Properties window, if you click on the background, you can change the background color to mauve, apply. Now you're done with this. Then you click inside the bar, right click, properties window. Now you can change the color of the bar to this, say, apply. So you have this. You can do any number of things with it. Okay, you have again options, title, you can add a title, you can add a footnote, you can show your grid lines, whatever you want to do, you can do with it. Okay?
Ma'am, isn't
Okay.
it the same we
Yes,
did it in third question?
Yes,
Okay.
it is. It is. That is, yes. No. Third question, no. Third question is number of people living in rural and urban sector. Right now, what are you referring to changing the background color?
Yes, ma'am.
Yes. It is same for any graph you take out of SPSS.
Okay.
For any graph, whatever it might be. Okay. Now let us do a histogram with panel as gender. Okay, I need to hurry up, otherwise I will, yeah. So histogram, we have income here, and let me panel it using gender. So the histogram will now show me males and females separately. You can again have religion as your another panel, which will again give you all those 6 graphs, 7 graphs, 8 graphs, whatever it was, right? So these things, I guess, I leave it to you as an exercise. It's the same thing as we did in bar. Okay. Repeat question 2, household size, and plot a histogram. I guess all of you can do that. It's very easy. You simply need to push in graphs, histogram. So instead of these, I need household size. So I'll push OK here. Now see how this graph is different from the income graph. As you can see, this 2 is in the middle of this bar, right? That means this is the mid value. This 2, 4, 6. So that means this is 1, this is 2, this is 3, this is 4, 5, 6, so on and so forth. So in this case, you do not need to change your bin length because you have an interpretation here. It is like around 2 households have household size 1. Around 15 households have household size 2. Right? Around 120 households have household size 4, because these are the mid values of the intervals. So here your life is a little easier, SPSS has done its work, and then you don't have to go around changing the intervals. However, if you have data like this, which makes no sense, or I've lost it, that was in the other one. So if you have data like 0 is somewhere, 10,000 is somewhere, you have got 6 bars in between. They are not, 10,000 by 6. You do not know the exact, there are decimals involved. So rather than get into that, define your intervals. I always suggest that. Okay. So this was all about histograms. Now let us move on to something known as a box plot. Okay. So the first question is box plot of age by gender. Let us try and do something about box plots now. Okay. So,
Excuse me, ma'am.
yes.
Ma'am, what is the use of this box plot, ma'am?
Box plot basically gives you a visual idea regarding the outliers and the range of your data and the middle point of your data. So visually, I will be showing you how to identify outliers in your data. When you're doing a regression analysis, you basically do not want outliers, right? Because that will push your pull and push your regression line elsewhere, right? So to identify those and to have some idea regarding the central points of your data, box plots are extremely useful, right? I'll explain as I go along.
To find out the mean, ma'am, is it?
No, not mean, not mean.
Okay.
The median, the quartiles, other quartiles, the interquartile range, and outliers. A mean has got nothing to do with a box plot. It is more quartile based. Since second quartile is the median, so you'll get the median as a middle point. Okay.
Okay, ma'am.
Yes. I'll clarify as I go along. Yes, Neha, the demographic profiles, it depends upon what you want to analyze. My data is basically socio-economic demographic data, so that's what I'm doing out here, right? Acha, let's move on, otherwise we won't finish. Again, this comes along.
Box plot.
Yeah, box plot. So I'll be doing a simple box plot first. I've forgotten my question. I was doing a box plot of age by gender. Okay. So I'm trying to find out, my age is also a scale variable, right? It's a quantitative variable. So you need a quantitative variable to find the median, range, outlier. It has to be a quantity, right? So I'll start off with age. So simple, I click here. So I'm doing this for age, so it goes under my variable, and I'm doing it by gender, so that goes in the category axis. This doesn't have to be quantitative. Only your main variable of interest has to be quantitative for obvious reasons. Okay, so I'll press an OK here. Yeah. So as you can see, for males as well as females, the medians are almost the same, right? And you see, this is giving me the maximum of the data, the top part. This is giving me the minimum of the data. So I do have males and females who are just about a year old in my data maybe. And my middle point is around the 30-ish mark of my data, the median. This is my upper quartile, this is my lower quartile. That is 25% of my data lies below this, around 17, 18, it must be something. And 75% of my data lies below this 45 age or something amongst males. I think the female interpretation is also very similar. Now, this doesn't have any outliers, so it is not showing me. I'll do something with income, which will have outliers eventually. See, if you want to cross-check something like this, what I suggest is you go to frequencies, then you go to your age variable, go to statistics, median, quartiles, minimum, maximum, continue, okay. See, oh, this pie chart keeps coming. See, as I told you, the median is around 30. Okay, minimum is 0, maximum is 87 around about for someone. Yes, does it match? The whisker below is your minimum. The whisker, this is called the whisker. This is the maximum value in your data. So the minimum value for age in my data is 0. The maximum value for age in my data is around 87. Okay, so that is validated by this. My first quartile is 16. See, I told you this is around the 15 mark, na? This box where it starts. This is my first quartile. So 25% of my observations are below the age of 16. Okay, 50% of my observations are below my median, which is 30. And 75% observations are below my third quartile, which is around 47. So this is how you interpret a box plot. And this will be more clear in my next example. So, let me try and show data labels. Sometimes SPSS misbehaves and doesn't show. Let me try. I've double clicked here. I've clicked here. And in my option elements, data label mode. Does it show? No. See, sometimes it misbehaves. Okay. So I knew this might happen. So it's not showing me data labels presently, but then you can definitely bring it. Bar options. So here also you can reduce the length of bar by clicking inside the bar, change the color of your bar, you know, chart size, this and that. So all of that you can do. So I'll move to my next question now, and yeah. Let me do number 16 first. Income versus gender. I'll show you where outliers come in. So graphs, legacy dialogues, graphs, legacy dialogues, box plot, simple. So income versus gender, right? So in the variable, I'll push in income and I'll write okay. So this is my box plot now. This means my income starts from somewhere above, a little bit above 0. The maximum income for males I have is around here, 20,000 within this range, mind you. I also have males earning 40,000 as I had seen, and that male is in 214th row of my data. See, can you see the number here under star 214, who is earning 40,000, a male? Let me go and check in the data view. Let us go to the 241st row. So you see 241st row is this. If I change my look, just a second, 214th row rather, not 241st, 214. 214th row is a male, is earning 40,000 rupees actually, and is an outlier in case of my data, which may end up skewing whatever analysis I want to run later on. So if I can identify this and delete this and run my analysis, maybe those will give me better results. Similarly for females, see, these are all outliers. The 285th row, 368th row, 387th row, let us check. 387th row maybe, let us check. Whether it is actually a female, has to be. 387th row, it is a female earning 30,000. So, which is above the range here. So range of the box plot. So you see this person is here. So what this is doing is, it is enabling me to identify the outliers in my data so that I can get rid of them before performing an analysis, or even otherwise you may want to have a look now that where is my data concentrated. So my data is basically concentrated somewhere between 0 and 25,000. And above that, there are only these many people, you know, around 10 or 15 people who are earning incomes above that. So it may help you visualize that as well. So I hope I have clarified the use of a box plot. The only thing I'm feeling sad about is not being able to click this data label, because that is, yeah, show data labels, value data labels. Yeah. Okay. For some reason it's not allowing. Maybe some other day when we sit for some other session. What will happen is then you can see the data values here, nothing else, nothing much. But here, everything above this marked by this round and star are outliers in our data. Okay. So this is the use of a box plot analysis. It gives you the concentration of data. Right. So let us income versus education level. I'll skip for now. I'll now do a heat map. Okay, so a heat map is actually one of the lesser used tools, or maybe I use it a little less because it is merely visual. It's not going to give you much out of it, or that's the way I feel about it, maybe. So for a heat map, what you have to do, it's a little bit difficult to find it out also. Different versions of SPSS have different options for going to heat maps. My version is 24. So here what I do is I go to graph board template chooser. Here I have a heat map, thankfully, because I brought it. Otherwise you need to do a little bit of mushakkat to bring it in. Yeah, so what ideally here you have to do is you have to select your variables all together. So two variables have to be nominal, one has to be scale, right? So I have taken sector and religion and income. So let me select in my data set sector, religion, income. Okay, so once you select these, how am I selecting this? I have selected sector, I have pressed control with my left thumb. Then with the control pressed, I have left clicked on religion and I've left clicked on income. Now I can release my control button. So I've selected these three. SPSS automatically shows me what kind of graphs are possible with three values. Okay, so I'll select a heat map because we are trying to do something with a heat map out here. So if you go to the detailed section, you can see here the columns represent religion, rows, sector, color, income. It depends upon you. Yes, heat map, you want me to repeat again? Yes, I will do that. Just let me generate one. I'll show you again how to do that. For now, just the inference part, if you can please concentrate on. So it's up to you which nominal variable you want here, which nominal variable you want here. In the color section, however, you have to have a quantitative variable because heat map maps the values with higher figures with a darker color and those with lower figures with a lighter color. As a result, the color section will be completely quantitative in nature. Whereas in the other two sections, you can have your socio-demographic economic characteristics. Okay. So in the color section, you have to remember the data has to be quantitative because heat map will map a darker color against a higher figure. That is what it does. Okay. Right. So let me click OK and let me see what is displayed. You see all these beautiful colors. So color selected is red here. So the darker the red, the more the concentration of income there. So mean income is very high amongst urban Hindus and amongst urban Christians, Buddhists and others. So in the urban areas, except for those professing Islam, mean income is pretty high. Okay, in rural areas, however, mean income of Buddhists and others are pretty low because the color is very faded out here. Can you see? Comparatively amongst Christians, it's a little bit high, and amongst Hindus and Muslims, it is higher. So the darker the shade of the color, the higher the value of your quantitative variable. Right? Oh, I'm so sorry, Lena. Yeah, use of heat map is nothing. I don't find it very useful, except for visual purposes. You know, from here you can see that amongst Buddhists and others, the mean income is less in rural areas, and in urban areas, actually income is very much more if you leave out the Muslims. So that kind of a quick idea you can get from a heat map. Okay, and to generate it, I think someone was asking, you have to go to graphs, graph template chooser. There you have to choose two nominal and one quantitative variable, pressing the control button. Once you do that, your right hand side option heat map will appear and you can do it. Okay, now I come to my last bit for which I'll be using data set number 2. So just a little bit more of your concentration is required. I have opened my data set number 2. So I'll be trying and doing a plain scatter plot, not going into a correlation matrix. We don't have time also. So we'll be doing a simple scatter plot. Okay. So let me do a scatter plot between total expenditure and total food expenditure. We will see, if Angel's law is holding or not, or, if total food expenditure is increasing with increasing expenditure also. Like generally what happens, as Angel has said, that as expenditure increases, as total expenditure increases, the proportion of expenditure spent on food keeps on decreases. Okay, it keeps on decreasing, right? As the income increases. Here we are using total expenditure as a proxy for income only. So let me go to graphs, legacy dialogues, scatter plot, simple scatter, define. So maybe in my x-axis, I want total expenditure, and in my y-axis, I want total food expenditure. Okay. Now, you can of course create your titles and all that here. So I'll press an OK. So SPSS has given me an output, or oh no, I have to reopen my data set. Please pardon me. Data set 2. Okay. So graphs, this scatter, simple scatter, define, x-axis, y-axis. Okay. So here you see it shows me a fairly linear relationship between my total expenditure, which is used as a proxy for income, and total food expenditure. Right. So it's showing me a linear regression line, almost. I mean, it's linearly related with a high correlation coefficient, maybe. So that is what my data is showing. Now, what else can I do with it? I can, of course, if I go to graphs, scatter, simple scatter, let me push in sector here, set markers by sector. You know what it's going to do? It's going to generate a scatter plot with sector 2, that is urban areas marked in green, rural areas marked in blue. So you can see the scatter of points by sector here, which I think is fairly useful. You see, the concentration is more linear for the urban sector than the rural sector. So all these kind of inferences you can draw from scatter plot, and of course you can go on exploring. So at the end, I'd simply like to say there is another option called chart builder, okay, which is inside your graph section only. So I was doing everything using legacy dialogues except heat map. Heat map, I used my graph board template chooser. Everything is available inside chart builder also. You see, there is a bar, there is line, there is histogram, whatever you want. I've clicked on bar, I can pull a simple bar here. I can define my push sector here, push gender here, and have a graph. You can do n number of things from here. The only thing is you have to simply drag and drag and drag. So this is also a fairly useful option for a lot of us. However, the most commonly used part is always from the legacy dialogues box. That also gives you all the options. It's more manual rather than the chart builder section. So I think I have hurried to the end of my session. Yeah, thank you all for your patience. So you can do a lot of things with this as well. You can change the background formatting, as I have told you, with the properties window, fill and everything. It's the same as in bar charts. Yeah, so it's 8:30 now. So thank you very much for listening to me patiently. Thank you.
Thank you so much, ma'am.
Thank you.
Madam Paramita, it was an excellent session.
Thank you,
no.
ma'am. Thank you so much, ma'am.
You're always very kind. Always.
Of the interaction, not because that I am kind.
No.
Lots of interaction was happening in the entire session.
Yeah, so yeah, thank you. Thank you. It's my privilege and an honor always, and that you give me an opportunity to share whatever little bits I know. So I'm very grateful to you.
Yeah, but these topics are very much less discussed, and I find very much effective. Like when we use this kind of analysis, diagrams, etc. in researches, it might be very helpful.
Yes, yes, yes. Yes, I agree with you.
So any queries for madam?
Actually, ma'am clarified everything then and there itself, sir.
Yeah.
Thank you. Thank you.
So ma'am, please check the chat box. There are lots of appreciation for you.
Yes, yes, I'm really honored. I'm really honored and I'm really grateful to everyone.
so
Thank
much,
you.
ma'am.
Thank you.
So since there is no more queries, I quickly request Tania ji to give the vote of thanks.
Yes, sir. Now that we have come to the end of the session, I would like to offer my vote of thanks to Madam Paramita Roy for taking her precious time from her busy schedule and grace our occasion. All the important technical parts she has taught us today are definitely going to add value to our research work and in the long run. Besides, I would also like to extend my gratitude to Dr. Dibjyoti Choudhury, Senior Assistant Professor, Assam University, and co-conveners Dr. Shravanti Meti ma'am and Dr. Taraknath Sahu sir for organizing such an informative session for all of us. I would also like to thank all the backend coordinators for their continuous assistance to conduct the session smoothly. Last but not the least, a big thank you to all the participants present here today. Without you all, it would have not been possible to make the session a successful one. Now, I would like to end the session by a quote by Sri Ramakrishna Paramhans. Through selfless work, love of God grows in the heart. Then, through His grace, one realizes Him in course of time. God can be seen. One can talk to Him as I'm talking to you. Having said that, I would love to end the session. Till then, stay safe, stay healthy, take care. Shubhratri.
Good night. Thank
Over
you
to you,
very
Dibjyoti
much.
sir.
Thank you, Tania. And madam has already shared her email ID. So if anyone wants that, they can take it from the chat box. And thank you again, madam, for your spending your precious time and giving us this valuable lecture. And I think it will be evident from this lecture that future sessions will be obtained from you in our FDPs in near future.
I'll be really honored with your graciousness. You're very kind always, Dr. Chaudhary, and I thank you from the bottom of my heart for giving me opportunities. Thank you.
Thank you, madam. So we can call it a day, and let us meet again tomorrow at 4 p.m. Any queries?
I have a query to you.
Please, please.
Sir, there was a message on WhatsApp group that we are supposed to submit an article or a research paper by the. So just wanted to know if there's some last date or something for that too.
Already mentioned in the message that last date is the last date of the program, that is on 17th.
Oh, by end of the FTP, we need to submit the
By
paper.
the end of the day, like before the last session, you should submit it.
Okay, sir. Thank you so much.
Any more queries?
Say, is it mandatory to submit the research paper? Say, is it compulsory?
See, we are not
Or
taking
we have
exam.
to go
So
for any
taking a
evaluation exam?
piece of work from you for examining, for evaluating your work, right? That you learned from this
Yes,
FDP.
sir.
And that is
Yes,
why
sir.
the paper.
Okay, sir. Thank you.
Any other queries? Okay, thank you and good night.